Because I'm too lazy. There we go. All right, cool. So I'm just going to stay on that first little piece. All right. So let's see. The way I like to do this, all this terminology stuff, is to kind of make a story with it a little bit. Let me make sure I don't miss anybody. There we go. So let's say we're trying to, so one big thing you do with statistics, do we normally use the entire group of people we're trying to say something about? So for example, if I want to know, anybody into politics at all? Even if you're not, you know that there's politics. Yeah. You know that there's controversial president, for example, a little bit. I'm not going to get any viewpoints on anything. That's the last thing I want. But like leading up to the election, there are a lot of polls that were done that turned out to be kind of wrong and so forth. If we're trying to get a hold of the percentage of Americans who are going to vote for somebody, do they talk to every American? No, right? In fact, do they even talk to every likely voter? No. They poll a group of them. In fact, if you look at websites like Gallup or Politico or Real Poll or whatever, you'll see they do about 1,000, roughly 1,000, 1,200, something like that, people. And the first thing people say is, you're trying to say something about 200 million people, but you're only talking to 1,000. I don't trust that. Well, it's because you don't know stats yet. That 1,000 people is more than you need, to be honest, to be able to say it. The key is they have to be randomly selected. So if I wanted to say something about all Grossmont students, what word do we use for that collection of people, or that collection of things? Population. So my population, now you get to see how poorly I write. My population is a collection of everything or every person that I'm trying to say something about. I'm trying to describe in some way. So in this case, for example, all Grossmont, I like how I capitalize all Grossmont students. Okay. Now, if you didn't know this about me, yes, that is my handwriting. Thankfully, I can read my own handwriting. I had a teacher once that somebody said, "What was that first line?" And he says, "Does somebody remember what I wrote?" Oh, yeah, that's when I would retire, right there. So I got a population, I got a group of people I want to say something about. So, of course, in order to analyze that group of people, we take what? A sample. So sample is a subgroup of the population . Got it. Now, so for example, you guys would be a sample if I decided, what am I trying to say? I don't think I've said this yet. What do we want to say about Grossmont? What are you curious about? Like the percentage of people that drive a Ford or something stupid like that. What are you interested in about the Grossmont students? What would you like to know about all Grossmont students? Don't say their credit card number. Second? Majors. All right. So let's say the percentage of Grossmont students majoring in math. All right. So a sample could be you guys. A sample could be you's guys. In your notes, you say this class or whatever the hell. You guys with me? So you are a sample. You're a sample. Are you a good sample?
No.
No. And I'm not saying you guys suck. Why are you not a good sample?
Too small or tainted.
It's not that you're too small. This is a good size, to be honest.
We're all in math.
I love it. Sweet. I'm hearing a lot of beautiful stuff. Specifically because the thing ended up being the percentage majoring in math, you would think that there might be a higher chance somebody in here could major in math rather than just a random gross one student, right? And that's the other thing I heard. You guys weren't randomly selected. How were you selected? Well, you signed up for this course, right? So why is it not a representative sample? Who might I be leaving out?
The math major students.
Well, no. I mean, there could be math majors in here. And English majors could take statistics, believe it or not. So who am I leaving out possibly? Who doesn't have a chance to be here? People that don't need statistics. People that don't come to Grossmont at this time. You know, people that work 9 to 5 the whole week. When are they going to come to class? After 5 or before 9. Holy shit. You guys with me? So there are entire groups of people that cannot be in this sample. Is that cool? The people that hate me. And they're out there. I know all too well. Like, yeah, I'm just, well, then they can't be in my sample. That's not representative then, is it? Right? And if they hate me, they're probably not math majors. Okay. So it's not that you're bad people. It's that you're what we would call a convenience sample. Why does that make sense? Because for me to survey you is unbelievably convenient. I didn't have to do any work to try to make sure you're random, that you're representative. You're just right here. You're captive. Fill this out or you fail. Okay, shit. Right? Okay. Now, I've kind of already, I wanted this in the background of this, and I didn't start off that way, but we decided we're going to do the percentage of gross one students who are majoring in math. So that would be the third general thing, and actually it's the first thing really is, what are you trying to say about the population? And very often it's going to be some kind of numerical description, the average this, or the median this, which we are going to talk about later, or the percentage that do this, right? So that's what's called, you got to love this. The numerical description of the population is called a parameter. Notice how they both start with the letter P. Intriguing. It would be almost too much to believe if the numerical description of the sample started with an S, but it does. Holy shit. So if you mix those up, I don't know what more to do for you. A parameter is a numerical description of a population. So in this case, example, percentage of Grossmont students majoring in math. Now, a sample, if I describe a sample, it's what we call, now believe it or not, it's what we call a statistic. The word statistic actually has meaning in statistics. It's crazy. So statistic, it's the same thing as a parameter. It's exactly the same thing. In fact, I'd say it very similarly, right? So the statistic describes a sample numerically. Parameter describes a population numerically. Normally, the word that kind of gives away that it's a parameter is if I said something like 12% of all Grossmont students are majoring in math versus 12% of the 80 Grossmont students I sampled are majoring in math. One is a parameter. The other one is a statistic. Right. That's one of the words that make you sound drunk. It's like judicial system. It's not me, Your Honor. It's judicial. By the way, that's Dana Carvey. Dana Carvey came up with that. It's not me. A statistic, a numerical description of a sample. So if you are my sample and I say 12% of you are majoring in math, well, actually, let me just do this. How many of you guys, anybody majoring in math? I love it. 1, 2. I love it. That's actually more than I expected. So 2 out of 57, somewhere under 4%. I love it. You guys really? So that would be a statistic because that number describes the sample. I love it. SSPP. All right. Cool. So far, so good. All right. Now, how am I going to gather this information? How am I going to get to this point where how did I just get to the point where I was able to say somewhere under 4%? Sorry. Data. How did I collect the data? Counting, exactly. But before I counted, I had to ask a question. I love it. So to get the data are answers to the question. And the question is related to what we call the variable. So we have the variable, which is exactly what you would think. The variable, why do we call it a variable? This is a holdover from algebra, right? Why is it called a variable? So like the letter X.
It's able to vary.
It's able to vary. It's able to take on all kinds of things. So with the way I just asked the question, I said, who is majoring in math? You're either a no or you're a yes, right? I like it. So that would be the possible outcome, the possible values of the variable. How are we doing so far? So the variable is related to the question. In this case, the variable was, are you majoring in math or not, right? And then the data would be a collection of all the yeses and nos. You guys, okay, I like it. So the variable is related to the question. You would ask. And the data is a collection of all the answers.
So are the people considered variables?
No, each person in this case would have a different data point. The variable would be the question you're asking.
Okay.
And each person would provide their own value for that data point. Yeah. I like it. Yeah. Well, we'll see how this goes. Now, here's where I make sure I didn't skip anybody. Not going to do you yet. Nope. Good. I like it. Okay, cool. I like it. Good. So how are we doing so far? I mean, this is all stuff, most of this you know already. Those words you knew, the definitions are a little bit specific. But right here, this is what got me through the first time I ever took stats was, if you just think about, if they ask you, what's the variable in the situation? Say, if I was a person trying to answer this, what would I ask people? That's the variable. What would you ask people? That's the variable. What kind of answers could I get back would be the data. If you think about it like that, it's really easy to identify what's what. I like it. Now, what kind of data could I get? The data that I just got, well, to be honest, was a hand raise, but it related to yes. And the data I got from everybody who kept their hands down was no. That is very different data than if I asked, how old are you? Right?
Yes.
Then that would be truly numerical data. You with me? So can I take an average of yes and no? No, I can't. It's kind of like trying to take an average hair color. Right? You'd have to first add all the hair colors. Well, how the hell do you do that? What is green plus brown plus bald plus, whatever. You guys with me? I don't know what the shit that is. Pineapple. And then divided by, So the next thing we're going to do is talk about the different types of data. Because you have to know what you can do with it depending on what kind of data it is. And really, this is really mostly just so that when the words come up, you're not completely taken off guard. You know what the words relate to. So what kind of data is there? Oh, look at that. It's like getting up to the top of the mountain with snow on it and being the first one to walk around in. All right. All right. So types of data. There's a few different ways to break data down. The first way is very high level. It breaks it down into two types. Quantitative and qualitative. So the root word of quantitative sounds like what? Quantity. I love it. And the root word of qualitative is quality. So you have a certain quality versus a certain quantity. Which one is going to be the truly numerical one?
Quality.
Exactly. Quantity. Quantitative would be numerical. With me? I like it. Qualitative is a quality. It's categorical. It's name data. Quantitative would be truly numerical data. So what do I mean by truly numerical? This was funny. One intersession, I had basketball players in my from the women's basketball team, right? And I said, if your jersey number is 17 and your jersey number, I asked them what their jersey numbers was, and your jersey number is 13. 17 minus 13 wouldn't really mean anything. Are you guys with me so far? But then they said, yeah, it's Michelle, because her number is 4. I'm like, shit, all right. But in general, your jersey number doesn't indicate something numerical about you. It's like another name for you, right? Social security number. Zip code. You subtract 2 zip codes. What does that mean? Nothing. It means you have too much time in your hands, right? Okay. So quantitative, truly numerical. What does that mean? You can do all the normal computational stuff. You can add, subtract, and it. So truly numerical. Not just that they involve numbers, but they're truly numerical. The numbers are actually measuring something. Yes?
Wouldn't that be the yes and no? The yes and no?
No. Yes and no would be qualitative. Because they're just, can you find an average? No, I can find a percentage of people that answered yes. I can find a percentage of people that have blonde hair. I can't find an average of people. I can't do the normal computational stuff. I like it. So this is truly numerical data. And this would be, qualitative would be categorical data or name data. Not name, there you go. Name data. Okay, so like here, there would be zip code, type of car, blah, blah, blah. Anything that has just names. Maybe they're numbers, but they really are just names. Like your jersey number is your name. Social security number is your name. It's another way to reference you. Quantitative, actually numerical. That's measuring something, or I can do something with it computationally. Okay, I like it. So far, how are we doing? Okay, nothing too major. So these normally are really easy to tell which one it is. Pretty easy. The next thing I'm going to talk about normally is not quite as immediate. Okay. Yeah. So levels of data. 4. I like it. Somebody's planning out their notes. I like that. There are 4 levels of data. 2 of them pretty much correspond to qualitative, the lowest levels. And 2 of them correspond to quantitative. There's just a few like overlaps or whatever, but mostly that's what it is. So the first 2 kind of go together. It's been a while. Here we go. Nominal and ordinal. Anybody like Stephen King?
No.
Read any Stephen King novels? Like somebody had a really adversary. No. Oh shit. If you like Stephen King, you should also read Richard Bachman, because that was Stephen King's pen name, also called Plume de Nom. Why am I talking about this? Because I didn't take my meds this morning. No. Nominal name data, right? Plume de Nom is pen name. This is nominal. It means purely name data. Now, the definition doesn't make sense until you take the next level into consideration. Ordinal is name data that has a certain order to it. I love it. Right? So if I just said cars out in the parking lot, and you come back and say, well, I saw a couple of Hyundais. I just like to say the word Hyundai. A couple of Hyundais, and I saw some Kias, and I saw some Fords, and I wouldn't go, wait a minute, H comes after F. Is the alphabet? No. Is there an order that the car names have to be in? No, there really isn't. There's no order that they must be in. If I had a restaurant and I made up a bunch of little survey, you ever been in a restaurant and they're like, please rate your experience, right? And if mine said, was it fair? Was it excellent? Was it poor? Or was it good? You guys understand what I just said? Fair, excellent, poor, good. What would you say?
Fix this.
The hell? No. What order? It's supposed to be, from worst to best or from best to worst. What the shit is this? Are you trying to trick people? Do you see what I'm saying? There's an order that those words have to be in for it to make full sense. That's ordinal. Not can you put it in order, but must it be in order for it to make full sense. So this is purely just names. Just names. This is, on top of that, there's an inherent order to the names. So please understand that every ordinal data is also nominal. It just has that extra piece. So now you see why we call this levels. They just keep adding extra pieces on top. So the next two are going to be this plus something. Okay, and they're not going to be names anymore. They're going to be, so now this is related to quantitative. So now there could be an inherent order. For example, like year of birth. Right? If it said year of birth and it was a drop-down list to pick from, and it went 1918, 1947, 1937, 1962. And you're like, the shit is this? Right? Where's my year? No. It should be in frickin' order, right? But it's more than ordinal because the year you were born is a numerical thing. Can you take a difference and does it make physical sense? Somebody tell me when, anybody feel comfortable telling me what year you were born?
96.
96. I was born, when do you think I was born?
64.
Yeah.
72?
You got it. You don't even know if you have a seat yet, and you're saying that kind of thing?
Sorry?
72.
72.
Yeah. So, yeah, you can stay there because you're going to... All right, you with me? So, what was the year? Sorry? 96?
Yes.
All right, so if you subtract 1996 minus 1972, does the answer mean something?
Yeah.
Yes, it means
The difference of age.
how much older I am, right?
24 years.
All right, you guys with me so far? I like it. Yes. Yes. Assume that you guys can all subtract. So the difference here, though, is if I divide 1996 by 1972, do I get a number? Yeah, you can do it. Does the number mean anything? No. The number doesn't mean crap. I want you to stop and think about that. Why doesn't it mean crap? Because does the year 0 mean the start of time? No. So 0 doesn't mean what it's supposed to mean in the scale of year of birth. Are you guys with me? Same thing with temperature. How many temperature scales do you guys know? A lot of you probably know 3, because at this point you've had some science. Anybody only know 2? You're okay? If you only know 2, that's actually fine, because the third one's a little bit freaky. There's Fahrenheit, Celsius, Kelvin. Good old Lord Kelvin had to go and wake up one morning and go, let me screw everybody. But the Kelvin one is true. It's true because 0 in Kelvin would mean absence of energy. That's that. You ever heard of absolute zero? And I actually was doing experiments at Old Dominion on the East Coast with getting close to absolute 0 rubidium atoms, and they do all kinds of weird shit. So, you don't want to get anywhere near that yourself. But absolute 0 means the absence of energy. Does 0 degrees Fahrenheit mean the absence of energy? No, I can get colder. I can take energy, I can take it out of the system still. There's more to take out. 0 is not where it's supposed to be. So is 90 degrees twice as hot as 45? I don't know, that's sort of a subjective point, right? I would say 90 is twice as hot as 70, more subjectively, right? Woo, it's twice as hot as yesterday. Doesn't mean that it's, yesterday it was 80 and now it's 160 degrees. Holy shit, right? Are you guys semi with me? So here's the levels. This one's called interval. This one's called ratio. Ratio should be really in your face. Because what's the word ratio refer to?
Dividing.
I love it. It refers to dividing.